Welcome back to the deep dive. I want you to just imagine for a second that you're walking into this massive, state-of-the-art conference room, or maybe a really high-end theater.
Oh, yeah, those spaces can be incredibly intimidating if you don't know how they work.
Exactly, yeah.
Yeah.
And you walk up to a touch panel, you press a single button, and instantly, like magic, 100 things happen flawlessly all at once. The house lights dim down to this very specific lux level, the main projector drops from the ceiling, the lectern microphone unmutes itself, and the live stream just starts.
It looks completely seamless from the outside, right? Like it's just one cohesive brain running the whole show.
Right. But when you actually look at the underlying architecture, it's a completely different story. The gear running your audio, your lighting, the video system, they're all manufactured by completely different companies. They run on totally different operating systems. And, I mean, they effectively speak completely different languages.
Yeah. Oh, absolutely. The friction there is just massive. Getting all those disparate pieces of hardware to communicate usually requires this labyrinth of custom logic and gateway processors.
It's a notoriously difficult engineering challenge. How do all these completely different pieces of gear actually talk to each other without short-circuiting the operator's brain?
Well, you have all these isolated hardware ecosystems, right? And they need to execute synchronized mission-critical commands with virtually zero latency. But natively, they have absolutely no idea how to talk to one another.
Which is exactly our mission today. We're unpacking a really fascinating stack of technical notes about modern audio systems, specifically looking at the Violet Audio dMix 128 mixing console.
Yeah, the dMix 128 is a perfect case study for this.
It really is. But we're going to look past the standard audio specs, the raw inputs and outputs, to focus on this invisible piece of embedded technology inside it, which is an integrated OSC server. We're going to figure out what an OSC server actually is, why a sound mixer even needs one, and how this invisible technology prevents catastrophic operator errors.
It really is a game changer for system integrators, especially when you look at how it bridges the gap into natural language AI control later on.
Right, but to understand how that magic button works in the first place, we first have to learn the language it speaks. Okay, let's unpack this. OSC stands for Open Sound Control.
Yep, open sound control.
But looking at the sources we have, the name is actually, well, it's kind of a huge misnomer. Despite having sound right there in the name, OSC does not normally carry the audio itself.
No, none whatsoever. I mean, if you try to route a live vocal microphone through an OSC packet, you are going to be very, very disappointed.
Wait, if it doesn't carry audio, what's the point? Is it basically like a TV remote control? Because the remote doesn't contain the actual TV show, right? It just tells the screen what to do.
What's fascinating here is that strict separation between the audio and the control layer. You hit the nail on the head with the remote control analogy. In a modern network, you have protocols like Dante or MEDI or AES-67 doing the really heavy lifting.
Right, the actual sound.
Exactly. They are the ones transporting the high bandwidth, uncompressed digital audio across the network. If Dante is like the circulatory system pumping the blood, OSC acts much more like the nervous system.
Okay. The nervous system doesn't pump blood, it just sends the electrical impulses.
Precisely. It just sends the instructions that tell the muscles when to contract. OSC is functioning as that neural pathway. So when we talk about an OSC server inside the dMix 128, we are not talking about some giant metal rack mount server sitting in a loud IT closet.
Right, it's not a separate box.
No, it's essentially a lightweight software service, a daemon, running natively inside the mixer's own operating system. It just sits on a specific network port, listening for incoming commands.
Just waiting to be told what to do by external controllers.
Exactly. So an external device, a phone, a touch screen, a Stream Deck, sends a command over the network to the dMix 128's IP address, and the mixer obeys. It mutes a mic or moves a fader. And because OSC only handles the instructions, it remains incredibly lightweight and fast.
It's perfect for real-time machine control because there's almost zero overhead.
Yeah, the syntax itself is incredibly clean. It actually looks a lot like a web URL. If a controller wants to mute channel 4, it doesn't send some obscure string of hexadecimal code. It sends a human-readable address path, something like a /channel/4/mute.
Oh, wow. So it's structurally self-documenting. A human can actually read that and know exactly what it means.
Totally. anyone can look at that data packet and immediately understand the intent.
Cool.
And the OSC server inside the mixer receives that string, parses it, maps it to its internal DSP parameter, and executes the change instantly.
Now that we know OSC is just sending instructions, it unlocks this massive advantage, right? You no longer need to stand in front of a giant, intimidating soundboard to actually control it.
That is the fundamental paradigm shift here.
Because, I mean, the sources point out a very practical issue here. A modern sound mixer, especially something like a 128-channel console, is incredibly complex, and absolutely not every operator should have access to the full interface.
Oh, definitely not. A console like that has a terrifying amount of surface area for an untrained user to mess up. You've got hundreds of parametric EQs, matrix routing, insert points.
It's a disaster waiting to happen if the wrong person touches that.
Exactly. You absolutely do not want a venue manager or a substitute teacher having access to that entire control surface just because they need to, turn up a handheld microphone.
Right. In a traditional setup, what do you even do? Put gaffer tape over half the console?
Mm.
Or rely on those clunky user permission lockouts on the desk itself?
Yeah, the old way was a nightmare. But this is where the OSC solution comes in. Because it operates on this open API structure, system integrators can build completely custom, stripped-down interfaces tailored to very specific users.
So they're building bespoke user interfaces from scratch?
Yep. A venue manager might just get a simple iPad screen, and on that screen, there are maybe 3 volume knobs, a drop-down menu for the lobby background music, and, a foolproof, all microphones off, panic button.
That's brilliant.
And that's it. That is all they see. Or, for a different use case, a musician on stage gets a remote app on their phone that only controls their personal monitor mix. They can turn up the kick drum in their own wedge without having any programmatic access to the main house mix.
Here's where it gets really interesting, because this brilliant separation protects the full, delicate configuration of the dMix 128 from being accidentally ruined by non-technical staff.
Mm-hmm.
But at the same time, it empowers them to actually do their jobs without constantly calling the AV tech for help.
It provides incredible operational security. The lead audio engineer can spend days tuning the room, setting up the compression ratios, doing all the high-level work, and then they can literally lock the physical console in a closet.
Out of sight, out of mind.
Yeah, and daily operations are just handed over to the staff via these customized, idiot-proof OSC panels.
But giving a teacher or a bartender a simple volume knob on an iPad is great. Things get even wilder, though, when you scale this up to an entire building.
Oh, definitely. If we connect this to the bigger picture, professional audio rarely operates in a vacuum. It's almost always part of a larger production ecosystem.
Right, you're talking about show control.
Exactly. OSC acts as the glue for show control systems, things like QLab and theater automation. It allows audio changes to trigger precisely alongside lighting cues and video playback.
I really want to dig into that multi-purpose venue example from the text because I think it grounds the concept perfectly for the listener. Let's say you have a space that functions as a corporate conference room during the day, but then it's a live music venue at night.
The required changes for that turnaround are massive. You're talking about completely restructuring the architecture of the mixer.
Right. During the day, a manager hits conference mode. The OSC commands tell the dMix 128 to recall a specific snapshot. It activates the lectern mic, routes the audio to a live stream encoder, mutes all the stage inputs, and sets super safe volume limits so nothing feeds back.
Which is a very specific lockdown state.
But then, nighttime hits. A technician hits live performance mode. And the exact same mixer flips into a ridiculously complex setup for a 40-input live band, complete with heavy internal effects, routing, subgrouping, and 6 independent monitor mixes.
And if you had to manually repatch and reroute a 128-channel board for that changeover, it would take hours. Not to mention, it introduces a huge probability of human error.
You'd have exhausted engineers making mistakes, forgetting to unmute a critical bus channel or something.
Exactly. But with this automation, it eliminates those repetitive tasks. It drastically reduces setup time. A single macro command sends a highly dense OSC message to the mixer, and the entire personality of the building flips in a few milliseconds.
The audio mixer becomes this synchronous node in a unified state change. It's not an isolated island anymore.
And because OSC is deterministic, it happens identically every single time. It just works.
So what does this all mean for the physical hardware? Because clearly OSC is a powerful tool. But why are the notes focusing so heavily on the dMix 128's specific server? Why does it matter that the OSC server is built directly into the mixer itself?
That is a crucial distinction. Historically, getting different brands of gear to talk to each other required external computers or these really complex gateway processors.
Like a literal middleman box sitting in the rack.
Right, you'd have to take the proprietary logic from the control brain, send it to a translation box, and then convert it into whatever obscure hex code the audio mixer required.
Which just sounds like a nightmare for troubleshooting.
It is. It introduces so many failure points. You have extra physical cabling, another power supply that can die, and all this computational overhead that introduces latency. But because the dMix 128 has this server built in natively onto its main board, you eliminate that entire translation layer.
You just have fewer devices to install, direct communication, and a much simpler system design.
Exactly. It flattens the network topology. And plus, because OSC is an open standard, you aren't locked into a single proprietary ecosystem.
The walled garden approach.
Yeah, AV manufacturers love to build walled gardens where you have to buy their specific, usually overpriced touchscreens to control their gear. But OSC supports standard programming languages, everything from Python and C++ to JavaScript.
So a venue could hire a web developer 10 years from now to build a new interface, and it would still work.
Precisely. It future-proofs the investment.
Okay, but this brings me to a detail in the sources that I really wanted to push back on.
Yeah.
If OSC is this incredibly fast, reliable, open standard that does the job perfectly, why do the notes spend so much time talking about AI control? Like, do we really need AI in a zero-latency live production environment if OSC is already flawless?
This raises an important question, and it's something system architects are debating right now. On paper, it does feel contradictory, right? We just praised OSC for being rigid and deterministic.
Right. A specific URL path triggers a specific fader. No interpretation required. So why introduce a large language model, which is probabilistic and sometimes unpredictable, into that environment?
Well, the OSC and the dMix 128's MCP, the Model Context Protocol AI capability, they actually complement each other perfectly. They serve different purposes. OSC is ideal for structured, predictable commands, buttons and faders.
The deterministic stuff.
Yes, but MCP allows for natural language workflows. It acts as a translation layer for unstructured human intent. Because honestly, humans don't think in matrix outputs and decibel values.
That's true. An LLM out of the box has no idea how a specific mixer in a specific theater is configured, though. It can't just guess the OSC syntax, right?
Exactly. And that is where the Model Context Protocol is the missing link. MCP acts as the standardized bridge between the AI model and the local hardware environment.
So how does it actually know what's going on?
Through MCP, the dMix 128 exposes its current configuration, a machine-readable schema that maps out all its routing, its current states, and every available OSC endpoint.
Oh, so the AI is basically reading the real-time architectural blueprint of the mixer.
It is. So instead of a user having to know the exact OSC path to program a button, they can just verbally tell the AI assistant, hey, mute all the unused microphones on stage and reduce the FOIA level by 3 decibels.
Wow. And a traditional control system would completely fail at that because it doesn't understand the semantics.
Exactly. It has no semantic understanding. But the AI interprets that human intent. It looks at the MCP map, discovers that the Fourier zone is matrix 4, checks the current decibel level, identifies which stage mics are currently inactive, and then it compiles the exact rigid OSC commands needed to execute that request.
It does the logical deduction and then uses the system's own deterministic control pathways to actually turn the digital knobs.
Yes. The LLM handles the messy cognitive load, and OSC handles the ultra-reliable, lightning-fast execution. It drastically lowers the barrier to entry for the operator while maintaining the rock-solid reliability of the network.
That is just an incredible synthesis of technologies. I mean, looking back at our journey today, we've really explored how a built-in OSC server completely transforms a piece of audio hardware like the dMix 128.
It really ceases to be just a standalone mixer.
Exactly. It becomes this highly adaptable, intelligent hub. It communicates seamlessly with everything from a simple 3-button touchscreen for a bartender all the way up to an advanced AI assistant parsing natural language. It presents exactly the right tools to the right person at exactly the right time.
It really tames the inherent chaos of integrating complex technology stacks.
Which leaves you with a pretty fascinating thought to chew on. We've just seen how OSC acts as this universal, open translator for complex audio and visual gear, bringing order to total chaos. And it makes you wonder, when you look at all the other complex, totally disconnected systems in your daily life.
Oh yeah, like smart home devices.
Exactly. From your fragmented smart home gadgets to your wildly incompatible office software workflows. What other areas of our lives are just desperately waiting for their own open control language to finally make them work together seamlessly?
The hardware is rarely the limitation anymore. It's almost always the translation layer that's broken.
It really is. Well, thank you so much for joining us on this deep dive into the invisible language running our live events. Keep analyzing the structures around you, and as always, stay curious.